Hi, I want to discuss some point of reference like recursion. In real-time project, recursion is used most frequently. It is recursion. Function is calling itself again and again until it reaches its point. Suppose we want to make some factorial, 5 factorial. 5 factorial, the best thing will be what? 1 into 2 into 3 into 4 into 5. Yeah, like that only 120. But we have to parting this problem like that. We have to make it smaller. That is the bigger problem. From bigger problem, we have to convert it into the smaller problem. That is the main agenda, so that we can code like that way. Suppose example, bigger problem into smaller one. That one, suppose it is the 5 factorial. 5 into 4 factorial. Okay, 5 into 4 factorial, right? Into 4 factorial, again we have to do it. 4 into 3 factorial, right? Function is calling itself again and again until it reaches this point. Okay, 3 factorial, 3 into 2 factorial, right? 2 factorial, 2 into 1 factorial, right? 1 factorial, 1 into 0 factorial. We know 0 factorial is what? 1. Suppose 0 factorial 1 हो गया, 1 into 1 is equal to 1. Here no 0 factorial 1 into 1 is equal to 1. We are getting the point 1. Okay, you have to put that value in that. 2 into 1, 2 into 1, 2 factorial, 3 into 2 is equal to 6, 4 into 6 is equal to 24. But 24 if you put 5 into 24 is equal to 120. That will get like that only. Recursion over. That is one real life example. If I will put, we know the method of induction. Everyone know method of induction, right? Method of induction, how it, let me check. Suppose summation of I is equal to 1 up to n, 1 plus 2 plus 3 up to n. What is the formula of that? N into n plus 1 by 2, that one, right? Here, method of induction will prove if n is equal to 1. Like that we want to prove. For same value if n is equal to k, if n is equal to k plus 1. For every value if it will same, then we will prove that LHS is equal to RHS, then it is working like that, right? For n is equal to 1 is equal to 1. For n is equal to k, suppose that 1 plus 2 plus 3 up to k. It will be k into k plus 1 by 2, right? It is like that only, right? If n is equal to k plus 1, for that 1 plus 2 plus 3 plus k plus 1 term, k, no, up to 1 plus 2 plus 3 plus k, then k plus 1, k plus 1th term. For k plus 1 term, as per the formula, n into n plus 1 by 2, k plus n into n plus n हो जाएगा k plus 1 plus 2 by 2, right? That is, but if we will pattern and input the value whatever mentioned in equation 2, 1 up to k is equal to k into k plus 1 by 2, I'm putting formula of this term that is already mentioned in equation 2. If I will put 1 plus 2 plus 3 up to k, that is already I mentioned in equation 2, k into k plus 1 by 2, okay, plus k plus 1. If you will take LCM and put like that, that is 2, a common k into k plus 1, 2 into k plus 1, like that only, right? If you will common k plus 1, k plus 2 by 2, right? K plus 1, k plus 2 by 2. Whatever I mentioned, whatever I will put, that is same now. So LHS equal to RHS. That is the method of induction. And intermediate level, everyone learned that one, right? That is for getting the bigger problem, we parted it small chunks of problem. In real time, if we will search some terms in Google, suppose we will searching somewhat like say after required result, getting required result, it will type some say like say. Until and unless we will getting the required result, it will in that search engine it will type is it the cell, whatever you are looking for, like that. That is the function it is calling itself again and again. For coding, if you want to get, okay, suppose class factorial, okay, that is the class. If you I'll code it in Java, right? Static void string we have to make a method like that. Fact. Suppose return type will be, if you want to suppose 5 factorial, return type will be 120. So return type here int starting. Yeah, like that. Suppose we want to get the factorial of this, so factorial int f. Here see, every time we will put n minus 1 now, or the factorial 4, that is 3, that is 2, that is 1. Every time n, that is the number n is equal to 5. Every time 1 less, until and unless it meets the base case. Base case is equal to 0. Base case is equal to 0. 0 factorial is equal to 1. That is the universal truth, right? Okay. Return n every time fn. Like that. Or we will take the value int n is equal to 5 now. A short. Factorial of n. Factorial of n, and then we will calculate the value of the factorial of a number, right? I'll show you in terms of memory diagram. In memory diagram, it will be like that only. That's it. What? That is the main public static void string areas. What we will put, that is the main function. Int n is equal to 5. Main memory, whatever in stack memory, we'll calculate that one, right? That is the sysout, right? Sysout fact of n. Okay. N is equal to 5. For n is equal to 5, what will be right? Once. N is equal to 5. Return. What it will be written? F. Return I already put now. N into fn. N into fn. Like that. If n is equal to 4. Fn is equal to what? What will be? That is the fn is equal to 5. N is equal to 5. Fn is equal to here. Fn what will write? Factor n minus 1 will be 4 now, not 5. Return 5 into fn, right? 5 into fn. 5 into fn. Every time it is minus 1, 4 factorial, 3 factorial, 2 factorial, 1 factorial, 0 factorial, like that. If n is equal to 4, if n is equal to 4, f1 is equal to 3, return 4 into fn, like that. If n is equal to 3, that is the memory diagram, how it will be stored in stack, right? Fn is equal to 2, return 3 into fn, like that. If n is equal to 2, fn 1, return 2 into fn, right? If n is equal to 1, function fn is equal to 0, return 1 into fn. If fn is equal to 0, what's the memory diagram, how it will be stored in stack, right? Suppose if n is equal to 0, how stack overflow occurred in memory, I'll show you. If n is equal to 0, if n equal to what? N minus 1, 0 minus 1 is equal to minus 1, return 0 into fn, like that. It will recursively minimize. That is the stack overflow error, it will come. So will be put in a base case. If until and unless it meets the point, it will be recursed. If it will meet the point, then it will stop, like that. I'll put base case for n factorial now. We calculate the n factorial. I'll put the base case now. How it will 1 if n is equal to 0. I'll put now 0 factorial is equal to 1. 1 will get if n is equal to 0. Okay. N into n minus 1. Like that. That is the condition. If n is equal to 0, it will be 1. Recursed anyway. N into n minus 1 factorial if n greater than equal to 0. So we'll put the base case here. Return n into fn recursively. It will recursion, right? There is no basement in it. We have to put a basement. If n is equal to 0, return 1. That is the base case. If we will put this line, when it meets the base case, it will stop and we will get the 5 factorial is equal to 120. Please put it in your ID and get the result. That is the internal how recursion will work. In the bigger problem, how we'll pattern it to the smaller problem, and the function will recurse again and again until it meets its base. Oh, that is the problem. Also, how it will work through method of induction. Method of induction is through method of induction we can easily accumulate how it work. In intermediate level, everyone learned it, right? In summation of I is equal to 1 up to n, how we will calculate like 1 plus 2 plus 3 up to n into n plus 1 by 2, like that. If n is equal to 1, what is the value? If n is equal to k, if n is equal to k plus 1, how it will work from smaller terms, how we will calculate the bigger terms, like that. Sliding window, one problem is there, like that we can also do. That is how a recursion work internally. Thank you.